Good morning, friends. Welcome to Water Resources Engineering class. In the previous lecture, we discussed the theory part of the Lacey's theory, and before that, what are the drawbacks of Kennedy's theory also we studied. So, in the Lacey's theory design, we have given the formulae, simplified the whole process, more comprehensive, and let us see how to solve the problems using Lacey's theory in today's class. Once the problems are solved, what are the drawbacks of this Lacey's theory also? Then what is the comparison between the Kennedy's theory and Lacey's theory? So these three topics in this lecture, let us discuss one after the other. Once again, refresh yourself. First thing is, if diameter of the silt particle is given, calculate the silt factor. Or if silt factor itself is given, fine. Then directly go for velocity of flow. Q is given, F is now you calculated or given, find out what is V. Then calculate A. Again you know the equation for P. A and P are known. Find out what is B and D. And you know R is equal to Lacey's equation 5 by 2 into V square by F. And R is also equal to A by P. Do it. Check it whether both the solutions are same. Then finally find out what is the slope. So these are the steps. And for that, the general thing is, for us channel bed width is B, depth is D, and side slope is Z horizontal to 1 and Z is equal to half. This is the general thing if nothing is given. If they change, accordingly you can do it. We are doing based on that. So it is BD plus 0.5 D square is the area, and then basically it is P is equal to B plus D root 5, because this is nothing but actually D root 5. Let us take straight away the problem. Design a final resin alluvial channel to carry a discharge of 30 meter cube per second. The first one he has given. Q is equal to 30 meter cube per second in bed material with median size. D50 is the size of the thing, which is equal to 0.33 mm. Assume a trapezoidal section in final resin tends to slopes Z 0.5 to this, it is 0.5 to 1. That is what he has given. So now first thing is what you need to find out. What you require generally if you want to solve any problem, Q and F. Instead of F, what he has given? The diameter of the particle. So first step is find out what is the silt factor. Once the silt factor is found, then find out the velocity actually. Once the velocity is found, find out the area. Once the area is found, find out the perimeter. Once the perimeter is found, these are the two equations for the trapezoidal section. And knowing those two equations, knowing the values of what is A and what is P, solve for B and D, and this is what B and D values are. Right. Next, R is equal to A by P and R is equal to 5 by 2 V square by F. And these two equations almost, if I can say in water resources, 1.48 and 1.49, 1.485, that means almost 1.49 and 1.49 similar. So that means whatever B value, D value you are getting are almost same, are correct. Then bed slope equation, F to the power of 5 by 3 divided by 3340 cube to the power of 1 by 6, solve for it. That is the equation. So problem solving is straightforward and nothing complicated, no trial and error, no assumptions, straight thing actually. Again, second problem, same discharge is given, silt factor is given. So this problem silt factor he has given already. So find out V, then find out A, find out P, then put it the section actually. So this is one thing which you should really work for it. Then once that is done, solve for it. Then after solving R. So the C value, the values are also almost similar. So that means the B and D are correct. Then find out the slope. While doing the problem, please observe how much slope we are getting. It is 1 by 5,000 to 1 by 6,000. Between that actually, generally the channels, irrigation channels slope actually. Then another problem actually in the same way, Q is equal to 50. I have done different discharges, right? 30, 15, 50. So like that. So this problem also, the moment you look into it, how I have done it, calculation of first step is what? F is given. So calculate V first, then calculate A next, calculate basically P next. A and P are known. So find out what is B and D. That's the next thing. For that actually what you need, for a trapezoidal section, what is A, what is P, you should know it. Then write that and accordingly calculate B and D. Once they are done, R equations, one is A by P equation, one is 5 by 2 V square by F. Use both the equations and calculate where the value is nearly same. So when they are nearly same, fine. So that means that if suppose they are completely different, there is something wrong in your calculation of something nearly B or D or whatever it is. So some calculation mistakes have happened, that you please check it. Then final thing is bed slope. So 3 problems. Lacey's theory is very straightforward, very easy for you also in the exams. Try to work out more problems in Lacey's theory. So now total how many problems we have given? On Kennedy's theory 2 problems, Lacey's theory 1 problem. Kennedy's theory 2 problems are what? Given Q, N, M, S. Find out the channel dimensions. Second one is what? Q, N, M, B by D ratio. Find out that. So this is the fundamental thing. Whereas Lacey's equations, the 4 equations which he has given, use the 4 equations and then solve the problems. So what are the defects in that? The first defect is keep true regime conditions. Lacey assumed that the channel achieved a true regime actually. A stable section with no silting, no scouring. But thing is generally the channels are affected by continuous changes in discharge, silt load and sediment gradation. So therefore permanent true regime is rarely attained. Applicability is limited to alluvial soils. That's what Lacey has told, and we also should remember that through non-alluvial soils, right, through clayey soils, this design doesn't hold good. This holds good only for alluvial soils. Then third one is lack of consideration of silt characteristics. So the whole silt characteristic he has considered depending upon the size of the particle actually. But size of the particle, shape of the particle, composition of the particle, the cohesion of the particles are not considered, though they are also going to influence the channel stability. That is the third point. Single value regime equations. So that means all his equations are depending on only 2 things. One is silt factor and the other one is the discharge actually. Generally he has taken the entire things are with revolving around this. But in practice, the multiple combinations of these parameters can exist for the same discharge. So the theory oversimplifies the real conditions. Next one is seasonal and variable flow conditions. Natural rivers or irrigation canals experience wide seasonal fluctuations in discharge. But Lacey's theory assumed that discharge is constant. So it cannot handle the variable or flood flows realistically. Then simplified velocity silt factor relation. Lacey velocity equation V is equal V square. That means what he has given is equal to V is equal to square root of 2 by F into R does not accurately represent velocity sediment relationships. It fails particularly in fine silt and very coarse sand conditions. No consideration of the bank material and vegetation. He never stability of channels are also influenced by the bank resistance and vegetation and side slope protection, but Lacey's theory ignores all these aspects. Most of the equations of Lacey's theory are empirical in nature and derived based on very limited data that is available for the canals in Punjab, but their universal validity for canals in other regions and much with different climatic, hydrological and sediment condition is doubtful. The same thing I can repeat in simple sentences. The theory does not give a clear description of physical aspects of the problem. It does not define what actually governs the characteristics of an alluvial soil. The derivation of various formulae are based on single factor and which is not adequate. Lacey's equation do not include concentration of silt as a variable because they have taken only F. Lacey did not take into account the silt left in the channel by water that is lost in absorption, which is almost 12 to 15%. The effect of silt attrition is ignored. Lacey did not define properly the silt grade and silt charge. Lacey introduced semi-ellipse as an ideal shape of the regime channel, which is absolutely, that means doubtful. Then strictly speaking, an artificial channel is not a regime channel, and regime theory is not completely applicable to it. Lacey's R value is applicable for steady flow only in steady flow, that too through incoherent alluvial soils. Now finally, let me compare the Kennedy's theory with the Lacey's theory. First thing is year of development. Kennedy's theory is developed in 1895, whereas Lacey's theory is developed in 1930, almost 35 years after Kennedy's theory. Lacey's theory has come into it. And concept is Kennedy's theory is based on critical velocity, the velocity at which the silt is kept in suspension. And this is based on a regime channel, a channel stable in shape and section carrying silt without silting and scouring. And governing parameter here is depth, here is discharge silt factor. And silt consideration not at all considered in this, whereas included silt factor depending on the mean particle size actually. Key equation is V0 is equal to CD to the power of N, whereas here it is Q of square divided by 140 whole to the power of 1 by 6 and P is equal to 4.75 root Q, etc. Two more equations are there. And type is, it is semi-empirical based on Punjab canal observations. It is semi-theoretical based on long-term regime conditions studies. Application, initial design, it is very useful for preliminary canal design in the regions where the conditions are similar to Punjab canals. It is a stable channel design widely used in practice for designing stable irrigation canal. And limitation is no account for silt properties, local applicability only in Punjab basically, cannot be uniquely determined channel, but because it is a trial and error procedure. Assumes regime conditions takes years to develop actually, semi-empirical equation not valid for all silt grades because we are assuming the silt grade and silt charge are constant. So that is, these are the main, what you call it as comparison between Kennedy's theory and Lacey's theory. With this, we have completed the problems on Lacey's theory, the defects of Lacey's theory, and also the comparison between Kennedy's theory and Lacey's theory. Thank you so much.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.